Hello everyone, I am Abiodun Komolafe, and I'll briefly discuss the effect of textile primer layer on the performance of screen-printed conductors on textiles. One of the easiest and direct methods for incorporating electronic functionalities into textiles is screen printing. It is an additive process as shown in Figure 1. It is very suitable for high throughput manufacturing of e-textiles. However, the rough surfaces of textiles demand that thick layers of conductors are printed to fill the interstices between the weave of the textile and primarily to achieve good conductivity. For e-textiles, it is often necessary to prime or treat the textile surface to reduce this printed thickness of conductor. This is done by applying a polymer film which allows thin and flexible conductor to be easily realized on the textile, as shown in Figure 2, which presents silver conductors that have been printed on fabrics with treated and untreated surfaces. In this case, the silver conductor on the treated surface is smoother and more flexible than the one on the fabric surface directly. The primer layer smooths the fabric surface. Figure 4 clearly contrasts the surfaces of a primed and unprimed textile. In this case, the textile has been primed with a polyurethane film, and the surface is clearly smoother than the unprimed surface. Figure 3 shows that this smoothness can be improved by increasing the thickness of the primer layer, which in this case is screen-printed polyurethane film. When the primer layer is printed on the textile, it moves the position or the location of subsequently printed conductors away from the neutral axis position of the textile, where the stress is minimum. This is shown in Figure 5, where samples of different conductors printed on textiles with primed and unprimed surfaces were subject to cyclic bending. As the number of prints increased, the thickness of the polyurethane film or primer layer increased. Hence, the conductor experienced more bending stress and a larger change is observed in its electrical resistance. Also, the range or the variation delta R in the electrical resistance of this conductor as it bends increased with the thickness of the PU film as shown in Figure 6. Figure 6 also tells us that priming the surface of a textile would benefit sensing applications where this range delta R or the size of this range delta R needs to be wider and where hysteresis needs to be minimized in measurement. To conclude, the primer layer enables the surface of textiles to be smooth enough to realize flexible and thin conductors. When these textiles are primed, the location of subsequently printed conductors is located away from the neutral axis of the textile, which makes it more sensitive to bending stress. This will benefit applications where the sensing range of a sensor needs to be widened and where hysteresis needs to be minimized in measurement. This work has been brought to you courtesy of the WebLex project funded by the EU, and I would like to appreciate the WebLex project partners all over the EU countries. To view more about our work, you can check our websites. Thank you for listening.